Okay, there we go. Alright, now I'm recording. Okay, so for this question, the question is asking us to like find the equation of the sum. Okay, now this particular problem might look a little weird. For reason number one, it's that you don't know if this is geometric or arithmetic. The question is not telling you if you're working with an arithmetic or with a geometric function. Okay, but recognize this from a arithmetic versus a geometric. The arithmetic, it's constantly adding something. Okay, now remember this thing, constant addition, listen to this, constant addition or repeated addition, it's multiplication. Okay, so if you see like constant addition, that's, wait, no, I'm confusing things here. Constant addition, it's multiplication, yes. So you will see in arithmetic sequences, you will see some number being multiplied. Okay, and that's technically just adding. Now, geometric sequences are actually a little easier to spot because either you'll see the multiplication going on, or you will see that some values are like this, being raised to some power. If you see a specific value being raised to some power, guys, that's automatically the first thing that should come to mind. It's, though, this is geometric. It's being raised to a power. Raising some function to a power, that's geometric. You can see on question on B, that's k as a power. Guys, on B you can see if it's raised to a power, again, that's going to be geometric. You can see on top all of these things are being raised to a power, that's geometric. On B, k is a power, so this is going to be geometric. Okay, now for computing the sum of a geometric sequence, you guys have your equation sheet with you guys? Yes, you guys are looking at the equation sheet for the geometric sum. Okay, so here's the equation sheet. Okay, we are working with the geometric sequences, or the geometric series. Okay, you can see up here the summation formula. This is for the sum. So geometric and the sum. So we're talking about these. Now remember, guys, there's two equations in here. The first equation here on the left, that's the equation for the sum up to a specific number. The second equation here, this is for the sum of the infinite sequence. So this is the equation that you use if you're adding up to infinity, if you're adding forever. Okay, so in this case, in the case of this problem, if you notice, we're adding up to this number. Okay, we're not going beyond this number, so we only add up to this value here. So that means we're going to be using the first equation. Now if you notice, for the first equation we need a few things. We need our a sub 1, which is our first number. We need the common ratio, and we also need to know up to which value we're adding. Okay, so this is the first value, 3. This is the second value, 3 times 1/3 raised to the first. Our third value is 3 times 1/3 raised to the second. Okay, raised to the second is our third value. That means that this 3 times 1/3 raised to the sixth, it's actually going to be our seventh value. Okay, well, if you're like looking at this and be like, okay, why to the seventh? Why is the seventh value? We'll check. Okay, being raised to the second power is the third value. Okay, it's just one more than the actual power. If you look at this one, the last value, it's being raised to the sixth. So what's one more? Well, that would be 7. Okay, if If you are like, I don't see it, I don't know how to find, you got 7 values, you can recreate this this pattern. Okay, you can check that 3 is the first term, plus 3 times 1/3 is the second term, then 3 times 1/3 raised to the second is the third term. Again, follow this pattern. It'll be 3 times 1/3 raised to the third. That would be the fourth term. Okay, and just keep recreating it. Keep going into like one by one. It shouldn't take you long. Oh wait, this should be fourth power. Then this should be to the fifth power. And look, one more. 1/3 raised to the sixth, and that's the last term. So technically, these three little dots stand for these terms in between. So we're adding up to this term. How many terms do we have in total? We have 1, 2, 3, 4, 5, 6, 7 terms. So we're adding up to the 7th term. That means n is equal to 7. Okay. Also remember, and another hint, the common ratio is whatever number you have that is being raised to a power. Whatever number that you have that's being raised to a power, guys, that's your common ratio. That's why my common ratio in here is 3. Okay. Of course, you guys also should remember that a sub 1, the first value, well, it's just the first value that you see at the beginning of the sequence. All right, so we've got everything. I'm just going to put everything into my equation and go ahead and solve this problem. Okay, there's my equation. So I'm going to just replace the r by 1/3, replace the n by 7, and replace a sub 1 by 3. So let me do that. So my sum, s, I'm adding up to the 7th power, so s sub 7 is going to be equals to 3 times 1 minus 1/3 raised to the 7th power, all of that divided by 1 minus 1/3. And that's it. I need to solve for this. I need to simplify this thing. Now simplifying this may be a little tricky. It kind of looks, I mean, you have fractions. Solving fractions is tricky, okay? So I'm going to try to explain this as simple as I can. Okay, first, what I'm going to do is I'm going to simplify the denominator. Okay, so I'm going to rewrite the top. And I can remember this fraction here that it's being raised to a power. I can rewrite that as 1/3, and both top and bottom raised to the 7. Okay, so technically I just distributed the power to top and bottom, to the value signs of the fraction, the top and bottom. So I have 1 raised to the 7 and 3 raised to the 7. Okay, now the bottom, it's 1 minus 1/3. 1 minus 1/3. If you forgot how to do this, here's a hint. 1 minus 1/3, you can rewrite the 1 as a fraction. You want common denominators. So 1 written as a fraction, it's simply 3/3. 3/3 is 1. A number divided by itself is always 1. Minus 1/3. Okay? Then from here, I can actually add these two. 3/3 minus 1/3, well, that gives me 2/3, because 3 minus 1 is 2, and the common denominator just goes along. So on the bottom, that actually simplifies to 2/3. Now I'm going to simplify over here this fraction. Okay, so on the top, I'm gonna have 1 minus, now get ready for this. Okay, 1 raised to the 7th That's 1 times 1 times 1 times 1 times 1 times 1 times 1. So what is 1 raised to the 7th? What is it? It's 1. It's just 1, because 7 times itself 7 times is just 1. So the top is 1. Now 3, well, that's going to be 3 times 3 times 3 times 3 times 3 times 3 times 3. We need a calculator for that. Okay, so 3 raised to the 7th, or 3 multiplied by itself 7 times. Okay, you can do just 3 raised to the 7th, which is that. If you're not that lazy, you can do 3 times 3 times 3 times 3. That's 4 times 5, 6, 7. So you get 2,187. That's at the bottom of this part here. 2,187. That's a big number. All of that divided by 2/3. You're gonna be like, well, Tafoya, that's huge. It is huge. It's a big number. Well, the denominator is a big number. The actual number is actually pretty small. Because if you divide all of this, if you put like the 1 under all of this, you actually get a pretty tiny number, 0.000 something. But that's another lesson, alright? This is what we have so far. Well, guys, the top, I want to simplify it, okay? I want to add these two numbers. Well, for that, I need common denominators. You have 1 right there. The number 1, again, to make 1 into a fraction, it's very easy. Look at this. That 1, I'm going to make it into 2,187 over 2,187. Because 2,187 divided by 2,187 is just 1. Minus this thing, which is 1 over 2,187. And then all of that divided by 2/3. I'm going to continue like on a separate sheet of paper, but I'm going to like continue downwards so you guys can see like all of the work. Okay, then from here it's on the top. I'm going to subtract 1 from 2,187, so that'll give me 3 times 2,186 over 2,187, and then all of that, it's divided by the 2/3 on the bottom. Does that make sense so far? Does it make sense how I got this thing on top from these two things? Okay, pretty much this thing on top, this thing that I have here, I got it from these two things. Okay, remember the denominator just goes along, and the tops they have to subtract. So I subtracted 1 from 2,187. That's how I got 2,186. Now simplifying this, it's also pretty easy. It may not look like so easy, but it's actually pretty easy. If I were to rewrite this, we did this back in Algebra 3-4. We have 3 times 2,186 over 2,187, and that is being divided by 2/3. How do I make that division into a multiplication, guys? If I change in fractions, when I'm dividing two fractions, if I want to change division into multiplication, what do I do to change division into multiplication?
You flip the second fraction.
I flip the second fraction
And change the symbol to multiplication.
and change the symbol from division to multiplication. So my second fraction is the fraction that I have on the bottom. So that 2/3 is my second fraction. So to change division into multiplication now, I have to switch the bottom. So that 2/3 will become 3/2. Boom. Now it's a little easier. Okay. This question, let me, Can you guys check how is it? How is the answer to this question? Is it given in fraction form or is it given in decimal form? Can you guys check on the back of this paper for question 9A? Is it given in fraction form or decimal form? Fraction? Okay. Here's the thing. We may have to simplify a little bit. Okay? Right here, I can see one way to start simplifying already. First thing you can check for, look for multiples. Okay? On the bottom, I have a multiple of 2 because I'm multiplying by 2. On top, I also have a multiple of 2. How do I know that on the top I have a multiple of 2? If you don't see, like, you don't physically see times 2 on the top, how do I know that there's actually a multiple of 2 on the top? You guys don't know? But let me tell you guys. Every time if you're multiplying, if you're multiplying however many numbers that you're multiplying, if one of those numbers that you're multiplying, one of them, at least one of them, is even, then that has a multiple of 2 in there. Any even number has a multiple of 2. I have a multiple of 2 on the bottom, and I know because of 2186, I know that this has a multiple of 2. So I know that I'll be able to cross this 2 out of here, and I'll be able to divide the top by 2. Okay, it's like if you have 8 over 2. You know that 2 will cancel from the bottom, and you'll be able to divide that 8 by 2, and that'll give you 4. So the same thing happens here. I know that I can get rid of that 2, and the top, this value will become half. Just that one, not the 3. Okay, just that one even one. But I'm gonna simplify everything. I'm just gonna multiply everything and see what I get. Okay. First of all, also the 3 that you have outside, that's understood to be like 3 over 1. Okay, because the number it's all by itself, it's understood to be 3 over 1. So this 3 you want to multiply by everything that's on the top. So on the bottom, I'm only going to multiply the 2, the 2187, and the 1, which doesn't really matter to multiply by 1. So on top, I have 3 times 2186, and that times 3 again. So on the top, I have 19,674. On the bottom, I have, it's going to be 1 times 2. Again, it doesn't matter to multiply by 1 because it'll give you the same value. And then that times 2,187. That gives me 4,374 on the bottom. Now I have a question. Is that the fraction that you have on the answer on the back? It's not? Oh, sorry. Is 19,674 the fraction you have on the back of the answer of the? No, it's not. No. All right. Let me try to get rid of this too. Again, also, when you get something like this, check out. The top is even, the bottom is even. That means that I can cut both of them in half. So that's what I'm going to do. I'm going to cut the top in half, and I'm going to cut the bottom in half. I can do that. That's legal. Because I'm doing the same thing to both top and bottom. So the 19,674, let me divide that by 2. That gives me 9,837. And then that divided by, I'm going to do the same thing for the bottom. I'm going to cut it in half. That divided by 2. That gives me 2,187. Is that what you guys get on the back? No, not yet. Ay. So there's other methods. Let me see. Okay, so the bottom is divisible by 3. 9, 10, 18. Yeah, the top is also divisible by 3. How do I know that? I'll show you guys a trick. The first thing that I'm going to do is, that means that I can divide these things again into, how do I say it? I can divide them again into by 3s. So the top I'm going to divide it by 3. 9,837 divided by, wait, actually I can divide by 9. Am I a little closer now?
Yes.
1,083 on top, and the bottom one I can also divide it by 9. 243. Is that the answer on the back? Let it. Okay. You guys may be wondering, okay, how did you know that I can divide by 9? Why not divide by 7 or by 20 or 5? Why 9? Let me show you guys a nice trick to know when something is divisible by 9. I can give you guys, okay, I'm done with number 9a. Okay, it was lengthy to, guys, all of this process that I did was just regular math that you did in 7th grade. Adding fractions, adding numbers, subtracting, multiplying, dividing. That's simple math, okay? It's a little lengthy, the steps. You kind of have to go like step by step so you don't get lost. That's why I did all of my steps. Okay, now on this part that was tricky, like the numbers are not even anymore. How did I know that I can divide by 9? Here's a nice trick. Check this out. If I give you numbers, I'm gonna start making just random numbers. Okay, 4, 8, 7, 3, 1. Let's see. Let me check if this is divisible by 9. If it's not divisible by 9, I'm going to add more numbers until I make it divisible by 9. But check it out. If I do 4 plus 8, that gives me 12, right? 12 plus 7, that gives me 19, right? 19 plus 3, that gives me what? What's 19 plus 3? 19 plus 3, 22. 22 plus 1, it's 20. 22 plus 1, 23. 23. Okay, let me add 5 and 1, and now this is divisible by 9. Don't believe me? Check it out. 4, 8, 7, 3, 1, 5, 1 divided by 9. Wait, no, got it wrong. 4, okay, let me check. Okay, 10, 17, 20, 29. Yeah, that's up to 29 actually. 29. Let me add a few more numbers. 29. That's 2 and 9. 29. What's after 27 in the times table for 9? 36. Okay, and 7. That should make it work. Okay, 4, 8, 7, 3, 1, 5, 1, 7. That divided by 9. Look, divisible by 9. There's no decimals. It's still a big number. Yes, I mean, and I made it so that it would be divisible by 9. Well, here's the thing. When you add the numbers, like the way that I was doing, if they add up to a multiple of 9, then it means that you can actually divide it by 9. So, yeah, well, these values here, when you add them up, they add up to 36. Is 36 a multiple of 9? It is. That's why this value is divisible by 9. If it's divisible by 9, then it's divisible by 3. Okay. So yes, I can just give you random numbers, guys. Like let's say they give you 72. Well, you check 72. 7 plus 2. It's 9. Is 9 divisible by 2? I mean, 72 is 9 divisible by 9? It is. I can add more numbers. I can add another 72 because 7 and 2 that's 9, and 7 and 2 that's another 9. So these add up to 18. And is 18 divisible by 9? Yes. So 7272 divided by 9, that gives you a whole number. I can add other numbers. 18. Let me give you guys now. Let me give you guys now 5 and 4. So check this out. 7 and 2 and 7 and 2. That adds up to 18. 18 plus 5. That's 23. 23 plus 4. That's 27. Is 27 divisible by 9? It is. 27 is divisible by 9. So 727254 divided by 9. I get a whole number. So that's what I did for these numbers when I got them. I was like, well, let me check if they're divisible by 9. So I did 9 plus 8 plus 3 plus 7, and I got 27. So I was like, definitely, the top is divisible by 9. I did the same thing for the bottom. 2 plus 1 plus 8 plus 7, and I got 18. Is 18 divisible by 9? It is. So I knew the bottom was definitely divisible by 9. And there's another trick that you can do for divisible by 3. For divisible by 2, if the value ends in an even number, then the value is divisible by 2. If the value ends for 4, if the value ends in a number that it's divisible by 4, then the whole number is divisible by 4. And there's more things to that. There's one for 7, but it's more complicated. For 6, there's another one for 6. For 5, I think for 5 it's pretty easy. If the number ends in 5 or 0, then the number is divisible by 5. And there's more. But that's for 9. That's the answer for 9. How much time do we have left? 4 minutes.